What's happening, dogs? Mr. Allen here with a little two-column proof involving a kite and proving a couple angles congruent. Okay, so I'm given that this quadrilateral, K-I-T-E, is a kite. Creative name for all the vertices, yes? And we want to prove that angle QET is congruent to angle QIT. Now, what I like to do oftentimes is I get one color that reminds me, like, hey, this is what I'm looking for, okay? So I'm going to do, I guess I'll do green for that, so it stands out. I want to prove that QET, this is what I want, QET and QIT. I want to prove those two are congruent. Now, I don't have that's congruent. I did mark my diagram, but I'm doing it with a different color that says, hey, I don't have this is what I want, so I have my goals in mind. All right, and I have a kite. So what do I do with that? Well, there's a lot of properties of a kite, okay? My diagonals of a kite are perpendicular to each other, so I get right angles. Let's see here. My sides of a kite, not all four congruent, but these two are congruent and these two are congruent. Sometimes they'll state that it's a kite with these two congruent and these two congruent. Otherwise, a lot of times they just want you to, I know it's a dirty word in geometry, but assume that it's drawn in that way because it is a kite, okay? So these two are congruent, these two are congruent. I've got four right angles there. And what else do I have? Well, one of my diagonals perpendicularly bisects the other diagonal. And it is based on that elongated shape here of the kite. These two are going to be congruent. This guy here, KT, bisects EI, right? It's perpendicular and it bisects it. Okay, so that seems like it's actually enough information. Let's mark this diagram up, shall we? And I will use, how about, I'm overwhelmed by my number of colors. I'll use this guy. So we said four right angles. So I'll just jot that down right here. We can just label one of them, and then it's going to follow through that all four of those are right angles, because these two are next to each other, so they're supplementary. If this is 90, that's got to be 90. Across from each other, those are vertical angles, so they are congruent, and so on and so forth. Okay. I said that this guy perpendicularly, that's the right angle, bisects, so these two are congruent. I also know that we said that ET, phone home, and IT are congruent, right? Because these two sides are congruent and these two sides are congruent based on it being a kite. Well, right now, I actually have enough information to prove two triangles congruent. And if I can get those two triangles congruent, can't I use CPCTC, corresponding parts of congruent triangles are congruent, to prove that those two angles are congruent to each other? Absolutely. So there we go. Now, if you don't, and actually I think there's actually a quicker way to do this, can I say that QT is congruent to itself? I can. So I actually have more than enough information here to prove that these two triangles are congruent. So you're calling how you want to go about this, okay? So first things first here, I'm going to pop my given down, right? So number one is that KITE is a kite, and that is the given information. Now I'm going to use this kite quite a bit here, properties of a kite, and we'll be writing those up over on the right-hand side, my reasoning. So first one here, let's go with the ET phone home and the IT department. ET is congruent to IT. Why is that? We could say that consecutive sides of a kite, or pairs of consecutive sides of a kite, are congruent. Some just say that it's a property of a kite. Let's see here. Pairs of consecutive sides of a kite are congruent. Okay. Again, some just say that they write down like it's KE is congruent to KI, IT is congruent to ET. It's kind of a weird one to write up. I remember that when teaching honors geometry years ago, that it was always kind of a weird one to write. Some may even just say definition of a kite. Okay, that could probably be acceptable right there, and I will also jot that down over here in white. You could just say definition kite for that one. I'd imagine most teachers are going to allow that as well. All right. So okay, so I've got these two congruent. We said EQ and IQ. Should probably have this open. EQ is congruent to IQ. And why is that? We said one diagonal perpendicularly bisects the other, right? if kite one diagonal perpendicularly bisects the other. I feel like these are rather informal statements here for our reasons, but hey, or informal reasons. It's pretty decent though. All right, follow whatever kind of properties your teacher is having you write up. Sometimes they are very specific as to what they want you to do. Sometimes they're rather lenient. I feel like in proofs, as long as you are supporting it properly, that's fair game. But some are very much sticklers and want certain names and certain ways of writing things and whatever. Settle down, bro. That's why people don't want to do proofs in the first place, because you're doing, being too hoity-toity about it. Relax a little bit. Let us reason through it. Let us explain this beautiful process that we have called the two-column proof. All right. Got these two congruent. I got these two congruent. Now I can either say that this is a right angle, as is this, because of the whole perpendicular bisector, but I think it might actually just be easier to say that QT is congruent to QT by reflexive property. Because if I prove that it's a right angle, I guess I don't actually have to prove that they're congruent. I can use hypotenuse leg as one of them. That's a possible reason. But I'm going to go this route. I feel like this is just an easier, cleaner way. Reflexive property. And now I've got my triangles congruent. Okay? So if you want to go the right angle route, we would be using hypotenuse leg right here. But since I went the reflexive property, we're using side, side, side. So triangle, we'll say QET is congruent to triangle QIT. And that is side, side, side. Now you may notice here that I left some gaps here and here to keep my numbers in line. All right? That was something that I really, really stressed when teaching honors geometry and regular geometry, is that you've got to keep these numbers in line. If I just have this all scrunched over here and this one gets really long, then it looks like it's out of order. It's very confusing, hard to read it. It'll lose you in the proof, let alone your teacher that's grading it. So keep those in line, especially on lined paper. All right. If you use multiple lines over here, drop down a couple lines over on this side and keep all of your numbers in check, in line. Cool. So now that I have these this triangle, this pair of triangles congruent, I can actually prove what I want. Angle QET and angle QIT are congruent. My reason? Well, if I have two congruent triangles, then their corresponding parts must also be congruent, aka CPCTC. Corresponding parts of congruent triangles feel about to be congruent. There we go. Boom. Done. Awesome. Fantastic. Sorry if that clap was really loud in the microphone. I apologize. But I was just super stoked. Super excited. There we go, guys. Little kite proof. Proving some angles congruent through congruent triangles. That's a common one right there in the geometry proof world. Thank you guys for watching. Have a wonderful day. If you have any questions, pop it in the comments. If you have a video request, let me know. Pop it in the comments or shout it out in the hallway. If you see me, if you go to school where I teach, be like, oh, Mr. Allen, Mr. Allen Math. Sometimes I respond to Mr. Allen Math more. I need a video on this. I got you, bro. See you later.